Hello guys, today we are going to discuss a full wave rectification. So first, what is rectification? And rectification is actually a technique through which we can convert an AC signal into DC signal. So in a previous lecture, we actually discuss half wave rectification. In half wave rectification, uh, one half of an AC signal is actually converted into uh, DC signal, and other half is removed or eliminated in a half wave rectification. For example, when we have a diode, for example, this is a diode which is connected into an input voltage Vi, and output voltage is taken from here. So when this voltage is like this, what will happen? So for positive portion of an AC signal, like this is an AC signal, positive portion, for example, this portion is positive pulse. So for this pulse, the diode is on, so it actually allows signal in the positive portion, and it will eliminate the negative portion of this signal. So it will actually eliminate the negative portion. So here in half wave rectification, half of a wave is converted into a DC signal. So for half wave rectification, we use this formula. We use this formula for an ideal case. This is the input voltage. So for example, when we have in realistic case and the diode is a silicon based diode, we use this formula, but for silicon based diode, Vk is actually equal to 0.7 volt. So this is a half wave rectification through which a half of the signal is actually converted into DC value, and we found the average DC value, average DC value through that formula VDC. So this is a full wave rectification in which a complete wave is converted, a complete wave is actually a complete wave is actually converted into a DC signal. Now, so for full wave rectification, we actually use a bridge network. So here in a bridge network, what will happen when a positive pulse is actually passed through this network? So here is 4 diode. So for positive pulse, D2 and D3 will on, and D1 and D4 will off. So the positive portion will be converted into a DC pulse through these two diodes. So what will happen when we pass a negative pulse through this network? So when a negative pulse is passed through this network, G1 and G4 will on, G2 and G3 will be off. So a complete wave is converted into DC network. One thing is to be noted here, that the output voltage will not change. The output pulse will remain the same polarities for the negative and positive pulse. The polarity of an output voltage will not change. So let's suppose when we pass this signal through this network, what will happen? So this portion is actually converted into a DC signal. This portion will also converted into a DC pulse, but the polarity will remain for both the pulse, will remain same for both the pulse. So VDC. So what formula will we use to find an average DC value? So to find an average DC value, so for an ideal case, we use this formula. This is an input voltage, this is an average DC value. For realistic case, we use this formula. Why we use 2 here? Because we are considering 2 diode in this case. So for silicon based diode, Vk is actually equal to 0.7 volt. We normally use silicon based diode. Now now when we are going to apply input voltage of 20 volt, we use that 20 volt voltage here, and we can get an average DC value for ideal case and realistic case. So this is the end of our lecture. Thank you for watching. If you have any question, ask in comment box.